Hello friends, once again welcome in this series of video lectures on polynomials. Today we are going to study about the division algorithm for polynomials. This is the division process by which we divide a given polynomial by another polynomial and we obtain the quotient polynomials as well as the remainder polynomials and their relationship. So let's start. We are going to study the division process and it would be easier to remember if we divide this process into various steps. So now let's have a look at the steps for the division process. In this process, first of all, we arrange the terms of the dividend and the divisor in the descending order of their degrees. Sometimes in questions we have been given the polynomials not in a standard form, so we have to arrange them according to the descending order of their degrees, and that is the standard form. So for understanding this, let's take an example. Suppose we have a polynomial p of x to be minus x plus 2x square plus 2. This is the polynomial, and here we can see that the degree of this polynomial is 2, right? But it is not the first term. So to arrange them in the standard format, we have to arrange them according to the descending order of their degrees. And also another polynomial, that is g of x, is 1 plus x. Here the degree of polynomial is 1, but variable will always be the first term and the constant term will be the last, and hence arranging these terms in descending order of the degrees, we get p of x is equal to 2x square minus x plus 2 and gx is equal to x plus 1. यहाँ पर हमें ये इस बात का ख्याल रखना है कि जब भी हमें क्वेश्चन दिया जाए तो उस क्वेश्चन में जो पॉलिनोमियल है उसे हमें स्टैंडर्ड फॉर्म में अरेंज करना है सबसे पहले. अगर उसे हमने स्टैंडर्ड फॉर्म में अरेंज किया होगा तो इट वुड बी easier to divide, right? So first important step for arranging for the division process of polynomials is to arrange them in descending order of their degrees. So then the next step after arranging the terms in their standard form, the next step is to get the quotient, first term of the quotient, and this can be obtained by dividing the highest degree of the dividend. That is, the dividend is 2x square minus x plus 2 and the highest degree is 2x square, and by it is divided by the highest degree term of divisor, that is divisor's highest degree term. Here we can see after arranging them in standard form, we have to divide the first term of the dividend with the first term of the divisor. Here we have p of x is equal to 2x square minus x plus 2 and second polynomial is g of x is equal to x plus 1. So we can write 2x square, which is the first term of the given polynomial, as product of 2x and divide it with the first term of the divisor, that is x. So here we can see that xx gets cancelled out and we are left with the term that is 2x. Now using this 2x as the first term of the quotient, we carry on the division further. Now as we have obtained the first term of the quotient, we multiply that first term, that is 2x, with the divisor polynomial. Now multiplying 2x with x plus 1, we get, when we multiply 2x with x, we get 2x square, and on multiplying 2x with 1, we get 2x plus 2x. So this term we get, and when we use this term we have to subtract this term from the dividend, and for subtracting we all know that we have to change the signs before subtracting the polynomials. So changing the signs, as 2x square is positive here, we take it as negative, and this plus will be turned into minus. So make one thing sure here, that after changing the sign, this sign would be the sign of these terms. That is, this will be minus 2 and this also will be minus 2x squared. Now subtracting it from the dividend, we get 2x square, both are cancelled out, and this is plus and this is minus, both are cancelled out. This term is cancelled out from this. Now we are left with this term, that is minus and minus. Minus minus will give us plus, so 2 plus 1 will give us 3, but the sign will be of the greater number. Here 2 is the greater number, and so it will give us minus 3x. And then we bring down the last term from the dividend, that is plus 2 below. So now this is the resultant term, and this is also our new dividend. Now continuing further, we repeat the process in the step 1 that we had done in step 1. That is, we divide the first term of the resultant dividend by the first term of the divisor. That is, minus 3x is divided by x. So we get this term. What is minus 3x? Where did we get it? We get it from here, the resultant dividend, and x is the first term of our divisor. Again repeating the same process that we had done in step 1, we divide minus 3x, that is the first term, by the first term of divisor, and here x and x gets cancelled out and we are left with the only one term, that is minus 3. So using this minus 3 as the next term for the coefficient, we get 2x minus 3, and multiplying this minus 3 with the divisor term, that is x plus 1. When we multiply minus 3 with x, we get minus 3x, and when we multiply minus 3 with plus 1, we get minus 3. Now subtracting this term from the dividend we got in the last step, we get here minus 3x and plus 3x, both are cancelled out, they give us 0, and here plus 2 and plus 3, plus and plus will give us plus, so we have to add 3 and 2, and when we add this 2, we get 5. So the remainder here is 5. So we get remainder as 5 as a remainder. Now we have to continue the process of division till we get a term with lower degree than the divisor. Means we have to get the term which is lower in degree than this divisor. Right, here we have got 5 as the remainder, and 5 has got no degree, that is 0 degree. Means it has no variable, so it is a 0 degree polynomial, and hence 5 has a lower degree than the divisor polynomial. So the division process here is completed. Now we have got some terms after that at the end of this process. So let's understand about these terms and the relationship between them. So first of all, we have got gx. Gx is nothing but the divisor polynomial, that is represented by x plus 1 here. If we represent the dividend polynomial by px, then px will be the dividend polynomial, that is 2x squared minus x plus 2. Then the quotient polynomial qx is the polynomial, that is 2x minus 3. And finally we have the remainder polynomial, that is given by 5. So here we have obtained the divisor, dividend, quotient and the remainder. So there exists a special relationship which we have learnt in arithmetic also, and same we are going to apply for the polynomials. So that relationship can be stated as dividend is equal to divisor multiplied by quotient plus remainder. In the lower classes we used to verify our division using this formula in arithmetics. Now same is applicable in algebra, and we verify our division process using this relationship. That is, the dividend polynomial, that is 2x square minus x plus 2, is given by the product of x plus 1 and 2x minus 3 and the remainder added to it. So this relationship is known as division algorithm. So we use this division algorithm to verify our division. Let's check it out how we use it. So to verify the division algorithm, we have the relationship, that is px is equal to gx multiplied by qx plus the remainder polynomial, that is rx. So now let's check it out. We have gx multiplied by qx plus remainder polynomial, that is rx. So writing these terms, that is x plus 1, that is our gx divisor, qx is our quotient polynomial, and rx is our remainder term. So when we multiply x with 2x, we get 2x squared. Then again multiplying x 1 with this 2x, we get plus 2x. Now this x is multiplied with minus 3, so we get x into minus 3 gives us minus 3x, and when we multiply this one with minus 3, we get minus 3, and the remainder term, that is plus 5. Now solving this, we get 2x square. Now here for these two terms we have plus minus. Remember a rule, plus minus is minus, so we have to subtract smaller number from greater number, that is 3 minus 2, it will give us 1, and the sign will be for the greater number, that is minus 1. So we get minus x after solving these two terms, and adding on these two terms we have plus minus is minus, so we have to subtract smaller number from greater number, that is 5 minus 3, and it gives 2, and the sign it will take will be of the greater number, that is plus here. So we obtain this term, that is 2x square minus x plus 2, and we can recall it or compare it and say that it is nothing else but our original polynomial. In this way we get the same polynomial on multiplying the quotient and the divisor and adding remainder to it. So this way our division algorithm is verified. Now we can state that if px and gx are two polynomials, we can find two other polynomials qx and rx such that the p of x will be equal to g of x multiplied by q of x plus r of x, where the degree of remainder, mark this point, it is important, degree of the remainder polynomial should always be less than the degree of given polynomial, or the degree of remainder polynomial must be equal to 0. Means these two conditions must be satisfied to complete the division algorithm. So this is about division algorithm. I have shown you the example and the method to solve it. You might get some examples or some sums on it in your board question papers, so try it out and solve them on your own so that you can check it out whether you have followed the concept or not. Initially it might be a bit harder because this is a new process, and after practicing it many times you will be mastering this process, so try them out. Then we move to another concept, that is the use of division method. By using this division algorithm, we can find out the zeros of the polynomials having the degrees higher than 3, right? We have learned in our last videos how to find out the zeros of the polynomials having degree 1, 2 and 3, that is linear polynomials, cubic polynomials and quadratic polynomials. We can find out the zeros using the relationship of coefficients and also their sum and product. In same way, when we want to find out the zeros of the polynomials with higher degrees, we can use this division algorithm. How we can use it? Let's understand it. First of all, we are going to divide the whole process into different steps. So let's make a note of these steps. First of all, if we are given some zeros, then first step is using these zeros and forming the factors. The zeros can be used to form the factors of the polynomials. In the second step, these factors are then multiplied together to get a term. मीन्स इन दोनों को हमें मल्टीप्लाई करना है, दोनों फैक्टर्स को, और मल्टीप्लाई करने के बाद हमें एक नई टर्म मिलेगी, एंड दैट टर्म विल बी द डिवाइजर पोलिनोमियल with which we will divide the given polynomial. In the third step, we divide the polynomial using the term which is obtained by multiplying the factors. And in the last step, we factorize the remaining polynomial to obtain the remaining zeros of a polynomial. So in this way, following these steps, we can find out the zeros of any polynomial of any degree. So let's find out, or let's look at an example to understand this. Suppose we have been given a question to obtain all of the zeros of polynomial 3x raised to the power of 4 plus 6 to the power of 3 minus 2x to the power of 2 minus 10x minus 5. We have to find out the zeros of these polynomials, where we have been given 2 zeros and remaining zeros are to be found out. So the zeros of this polynomial are square root of 5 by 3 and negative square root of 5 by 3. So let the polynomial p of x be 3x to the power of 4 plus 6x to the power of 3 minus 2x to the power of 2 minus 10x minus 5, and the zeros of the polynomial be square root of 5 by 3 and negative square root of 5 by 3. So from this it follows that the factors of the given polynomial will be x minus square root of 5 by 3 and x plus square root of 5 by 3. So now the next step is to multiply these factors to find a term which will be our divisor term or divisor polynomial. So multiplying the factors, we get a new term here. X minus square root of 5 by 3 multiplied by x plus square root of 5 by 3 will give us x square minus 5 upon 3. We have got this using an identity. I would ask you to recall which identity we have used here. You might be correct. The identity that is used here is a plus b multiplied by a minus b will give us a square minus b square. Here we have both similar terms. One is the difference and another is a sum. So the difference of squares of two terms, this identity is used here. So we have got the term x square minus 5 upon 3. Now we follow the third step, that is divide the polynomial px with the obtained term, that is x squared minus 5 upon 3. Now here we can see that all the terms are not given here because this polynomial is of the degree 2, means 2 is the highest degree, but the term with the degree 1 is missing here. Whenever you encounter such type of polynomials, you can replace the missing terms with the zero coefficients, right? So that would make our task of division easier. So we would also replace here the degree 1 of the term of degree 1 with zero coefficient. So as there are only two terms in the divisor, we add a term with zero coefficient, so the term becomes x squared plus 0x minus 5 upon 3. So this will be the divisor polynomial, and we will divide this polynomial using this divisor polynomial. So let's divide it. So when we start the division process, we all know that the first step is to obtain the first term of coefficient, and for that we divide the first term of the polynomial, that is 3x raised to 4, by the first term of divisor polynomial, that is 3x raised to 4 divided by x squared. Now 3x raised to 4, this can also be written as the product of 3 and x square multiplied by x square. Here we can see that x square and x square both will be cancelled out, and as a result we will be left with only term, that is 3x square, which will be the first term of our coefficient. So using this first term as our coefficient, we multiply it with divisor and obtain the term that we will subtract from the dividend. So on multiplying 3x squared with x squared, we get 3x raised to 4, 3x to the power of 4. Now 3 multiplied by 0, 3x squared multiplied by 0x will give us 0x cube, and then multiplying 3x squared with 5 upon 3. Here we can see that 3 and 3 are cancelled out, so we get 5x squared, so that is minus 5x squared. Now to subtract this term from the dividend, we change the signs, and hence we obtain the difference, that is 3x raised to 4 minus 3x raised to 4. This term is cancelled out. Here plus and minus, but 0, anything added to 0 will always give us that same number, that is 6x cube, plus or minus 0x cube will give us 6x cube. And here in the last term of this dividend we have minus 2x square plus 5x square. Minus plus will give us minus, so we have to subtract 2 from 5, we get 3, but sign of a greater number. Remember one thing, that after changing the sign we usually make mistakes. We take this to be the sign of 5, but actually the changed sign will be the sign of 5. So the sign of this integer will be plus, and hence it will be plus. So plus 3x squared, and then we bring this term with the result we got after subtracting from the dividend, that is the whole term will be 6x cube plus 3x squared minus 10x minus 5. Now again, to obtain the second term for the coefficient, we divide this term of the resultant dividend by the first term of divisor. This will give us, we can write 6x cube as a product of 6x and x squared divided by x squared. Now here also x squared and x squared are cancelled out, so we are left with the term 6x. Using this 6x as the second term of our coefficient, we multiply it with the divisor and we get this term. 6x multiplied by x squared will give us 6x squared, x cubed, sorry, and 6x multiplied by 0x will give us 0x squared, and 6x multiplied by minus 5 upon 3. Here 3 2s are 6, so we get 2 here, and 2 multiplied by 5 will give us 10. So 5 multiplied by 2 will give us 10x here, so we get this term. Now subtracting it, after changing the signs, we get the resultant term, that is 3x squared minus 0 will give us 3x squared, minus 10 plus 10x will also be a 0x, and here minus 5 is brought down with this term. So we get 3x squared plus 0 minus 0x minus 5. Now again repeating the process of getting the first getting the term for the coefficient quotient, we divide the first term of the resultant dividend by the first term of divisor polynomial. So we are left here, x squared and x squared are cancelled out, so we are left with only plus 3, and using this plus 3 as our last term for the quotient polynomial and multiplying it with the divisor term, we get 3x squared plus 0x minus 5, and resultant, after subtracting it, we get the resultant remainder as 0. So in this way we get the polynomial as a multiple of x square minus 5 upon 3 and 3x square plus 6x plus 2. So multiplying this, before that we take the common, that is 3. Here also it is a multiple of 3, and this is also multiple of 3, so we take 3 as a common and write it outside. Then bringing this term here, we are left with x square plus 2x plus 1. Now to find the remaining factors, we have to factorize this term once again. So we factorize it. X square plus 2x plus 1 will be factorized as, we know the identity that x plus 1 whole squared will give us x square plus 2x plus 1. This gives us that the 0 of this factor will be x plus 1 is equal to 0, and hence we have x is equal to minus 1. So as it has the terms x plus 1 whole squared, there will be 2 zeros at x is equal to minus 1. So the zeros of these polynomials are square root of 5 by 3 and negative square root of 5 by 3. These two are the zeros which have been given, and this minus 1 and minus 1 are the obtained zeros. In this way we can find out the zeros of the polynomials. So here we come to an end of this video. So please complete your exercise, that is 2.3, practice it well, and please do send me your answers to my number and practice it well, so that you can easily grasp this concept. That's all. Thank you. Goodbye.